Okay, let's do this. So I just want to, I feel like I rushed the end of last lecture a little bit. So I just want to, take some time and ask if there are questions and stuff. Maybe go over this a little bit more. Man, I turned the mic down, it's still way loud. Of sending, actually, let me switch gears a little bit here and pull up the homework doc. So at this point, aside from Docker and Docker Compose, which we're learning today and Monday, you can do up through Objective 3 in this code. HTTP basics, this is a GET request that returns a plain text response, a GET request that returns a 301 response. Oh, I don't even tell you it's a 301, spoilers. But a redirect and a 404. So 3 requests, 3 responses with different response codes, getting your headers set the right way, things like that. Objective 2, HTML, CSS, and JavaScript. This is playing with both opening files and getting your MIME type set to the correct type, and especially handling Unicode characters to get those emojis in the HTML. Bless you. To get those emojis in the HTML to display properly, you have to make sure your char set is set to UTF-8, and then you'll be able to get those. We talked about all that last time, and then very briefly at the end, we talked about hosting images. The big thing with images is to not overthink it. Read the file. You read a file as bytes, and that's your content. That's the content of your HTTP response, and then set the MIME type to the proper type. So up through Objective 3, you can do what we've covered in lectures so far, with the exception of running it in a Docker container, because obviously we haven't talked about that. And Docker is required for every objective. But you can write the code for Objectives 1, 2, and 3. So if that's shocking, surprising, if you have questions about that, let me know what they are. Because that's where I want you all to be at right now. Is, you probably haven't coded all that. Some of you have, but most of you probably haven't coded much of that. But you should be able to know what to do. Like, you should be ready to, when you find time, sit at your laptop and crank out that code. If that doesn't sound reasonable, I want your questions. Let me help you. Otherwise, I'm going to assume that everybody's up to speed, and I'm going to start talking about Docker. Yes, thank you.
For Objective 3, should we also create an error case for images, or should we just assume that in the input you're only be testing a valid input?
We're only testing with valid inputs on this one. Wait, let me back up just in case. That's not accurate. So these testing procedures, by the way, I haven't talked about testing procedures yet. The testing procedures are the same testing procedures I give the TAs. We don't have any secret script that we go by to test your code. This is how you're going to be graded. So if it's in the testing procedure, it's good as gold. If it's not in the testing procedure, we're not testing it. Often I'll do this in lecture. If I get a question like this, I myself will refer to the testing procedure because that trumps anything that I say. That's going to override whatever you hear that comes out of my mouth. So image name can be any image provided in the sample site, which implies that it's going to be a valid string, which is the way I intended, so I'm glad I have it written that way. Because I don't want you to have to check if it's a valid image. It's just an extra step that doesn't have anything to do with web stuff necessarily. And you should check that and then return a 404, but it's a bit much. That's why in the 404 text, I say it won't start with image. Any string chosen by the tester, but it can't start with image or users, where users is used for Objectives 4 and 5. So you don't have to do error checking on Objectives 3 through 5.
And then Docker Compose, is there supposed to be a dash in that? I just laid it without a dash.
Do I have a dash in there? It shouldn't be a dash. It should be just like this.
Yeah, that's a dash.
Where? Oh, in Docker Compose.
Yeah, I don't use that in the work.
So with the dash, you're calling Docker Compose and telling it to go up. Without the dash, you're telling Docker, which is different from Docker Compose. You're saying Docker, tell Docker Compose to go up. So it ends up being the same thing, but it's just a different way of going about it. It is two different commands, but they'll do the same thing. All right, I'm gonna take that as a good sign. The one thing, images, I can't say this one enough. So images are not strings. You cannot convert your image to a string. You're just asking for trouble if you do that. Images are not strings. I know I said this at the end of last time, but I feel like it was rushed. Some file I/O libraries are going to automatically treat your file as a string. In a lot of cases, that's what you want. So it might automatically interpret those bytes of the image as a string. Did I say files earlier? I meant images specifically. It might automatically treat that as a string. So you have to make sure that you read it as bytes and not as a string. Usually when you open a file, you put a B somewhere in there. That's about the least descriptive thing I could say. Like when you open a file, you have to specify, is this read mode, write mode, append mode? Usually you say open as R for read and then B for bytes. If you do that, then you should be reading your file as bytes in most languages, most libraries. That's the syntax for it. But whatever it is in your language of choice, make sure that you're reading it as bytes and not auto-converting your file contents as a string. That's fine for CSS, JavaScript, and HTML because those files are just strings. For your image, you can't do that. Image, you have to read it as bytes. And then once you have the image as bytes, most of the work's done for you. Like when we're dealing with strings, you have to do an extra step to convert it to bytes, to a byte array. But just read your file as an array of bytes, and you already have the body of your HTTP response. Slap it with a dot length, you have your content length, and that's it. The one trick to it is you have your headers that you're going to construct, which is going to be a string, and bytes, your image as a byte array, and you have to concatenate the two. So make sure you're encoding your string before concatenating the two, because you can't concatenate the bytes and the string together. Make sure you encode your string into a byte array before combining the two byte arrays. That's the big thing to think of. Yeah. Mm-hmm. For this homework, it'll strictly be those images. And those are the same images we'll use for testing. So we haven't talked about like dynamic pathing or anything. So for homework 1, you can hard code if the request is for /flamingo, if it's for elephant, if it's for eagle, and just hard code each one of those. Or else the homework 1 lectures are a bit, I don't have a lot of free space in them, so I can't fit dynamic pathing in there as well. Though I could probably just say figure it out. That is something that, it's not too complicated. But I think that is what I end up doing in homework 2, to be honest. But yeah, looks like the TA's got that answered. Yeah, don't read your file extension. Don't read the file extension of the images to find the MIME type. They're all the same MIME type. They're all JPEGs, right? That you can just say that that's the file format. Okay, let's get on to Docker. We have a style change in the slides for the Docker. This is the style that I was using. I left the Docker ones in the style. I feel like it fits Docker. So Docker and deployment. So we're going to learn 2 different things. Docker is dark and scary. I'd say that without the sarcasm. Not really. If you haven't used Docker yet, I guess I do have sarcasm there. But we're going to learn Docker, that's today, and Docker Compose, which will be Monday. So you do need to use Docker Compose along with Docker for your homework. So we're going to get you halfway there today. I thought I had a better punchline than that. We're going to learn Docker today and Docker Compose on Monday. So we got a little bit of vocab I want to hit you with. Is dev and prod, or development and production. These are the common names for the two different environments that our code is going to execute in. So development, that's where we're developing the code. That's our laptops, that's our desktops, that's our personal machines of any nature. That's our development environment. Wherever we're actively developing software, that's development, the development environment, or we'll just call it dev. You'll hear, throughout your career, you're going to hear dev a lot. If you haven't already heard it a lot, dev. That's where we write code. That's where all our action happens as the software engineers and developers. And then production, or prod. This is where your app is actually living and where it's live to actual customers. This is where it's running on your server and customers are going to your domain name and using your software. That's production or prod. That's the end goal of any software, is to make it to production and live in production for the rest of its life. That's our goal of writing software. So dev and prod. There's one big problem with these. You get it worked on my laptop, you push to production, and everything breaks. Nobody can use your app, users are upset, everything's broken. We're not having a fun time with that. This is common, even in courses. Obviously, you might have seen this, maybe not so much as we used to. I feel like we do what we can to get rid of this, but it happens a lot. Works on my laptop, I submit to Autolab, and Autolab says, your code sucks. It happens a lot. It happens in production, too. In live production out in industry, happens, too. You've used software that's buggy. You've seen this happen before. Lots of things can cause this. I'm not going to read them all to you, but lots of things that can cause this. So we need a solution for this. We don't want to just release buggy code that worked on our laptop. We don't want it to just be a roll of the dice. It works on my laptop. I tested everything. Everything's great. I push it to production, and it's broken. And I don't know why. It's just random. It just happens. We don't want that. So we got to come up with a solution, and a good solution is virtual machines. This is what you do in 220 or 250, I think, still uses virtual machines. You've probably taken at least one course that does this. They give you a virtual machine. You run the virtual machine on your laptop. That virtual machine's running in the grading environment, and you're both running the exact same environment. This is what we like. So now we don't have any mystery. We're running the same exact environment in dev as we are in prod. No surprises. Everything's the same. It's the same operating system. It's the same versions of all the software we're running. Everything's exactly the same. So we shouldn't get any differences between them. Running in dev is the same as running in prod. Excellent solution. We're good to go. This is great. Life is great with virtual machines. We also get some security solutions for this. So if you're running a web app that's not in a virtual machine, if it's just running on bare metal, as we say, but if it's running on the host operating system, it's running on your machine, if a hacker gains access to that, if you have a successful attack launched on your app, they can take down your whole machine. They can break your server. They can wreck your laptop, I guess, if you're running a web server on your laptop. They have access to things. Inside a virtual machine, they only have access to that virtual machine as long as the VM software is doing what it's supposed to be doing. It should be running in complete isolation of the host machine. So somebody can get into that VM, destroy things, but who cares? It's a VM. We delete it. We fix our code, patch the security vulnerability, and then spin it up again. Now, there are, of course, privacy issues still. If your database is running in the VM, the attacker can still steal a lot of data. It's still a terrible situation getting hacked like that. But they're not going to destroy your machine and have complete reign over your entire machine. We could also run multiple virtual machines on the same machine, on the same physical machine, and have multiple apps completely isolated from each other, but running and serving different sets of clients or whatever you want to do with them. I do that for the course websites, CSE116.com, CSE312.com, and several others. They're running in their own containers. I know I'm talking about VMs here, but they're running in their own containers, and they're completely isolated from each other, which means I can use, I mean, I don't in this example, but I can use different versions of software. Maybe one of them I need Python 3, one of them I need Python 2, just run them in different environments. And the security I just mentioned implies that somebody gains access to your machine or can run arbitrary code. We have arbitrary code execution attacks where somebody gets their code injected on your server and is able to execute their code like that, execute their code on our server. This is always a very devastating attack. If somebody knows how to exploit it, it's very dangerous. But there are some cases where we have to do this. Like, that's the nature of the app. Autolab, the whole point of Autolab is to run other people's code. So what happens if you submit attack code to Autolab? Well, I don't want you destroying the whole server and taking down everything. I don't want you stealing other people's grades and compromising grade books and stuff. I don't want any of that. So, for example, in Autolab, it's a separate container for every single submission. A new container is built, and you can wreck that container. That's fine. That container is about to be destroyed as soon as your assignment's done being graded anyway. So virtual machines, or as we'll talk about, containers, are going to allow us to run untrusted code by running it in isolation. AWS, Heroku, DigitalOcean, any hosting service also, by the nature of the design of the product, they have to run untrusted code. So they're all going to have similar solutions where they're going to give you a virtual machine where you have access and you can't wreck other people's stuff. If AWS just said, oh yeah, here, you can go into this machine where all kinds of other people are running their stuff also, and just don't look at other people's stuff and don't break it. That's a bad business model. They're going to give you an isolated environment. So lots of good uses for these virtual machines, or let's talk about containers, which is actually what we're going to use. Containers, not so new anymore, but they came on the scene and just completely took over what virtual machines were doing. They're effectively lightweight virtual machines. So you can run a separate environment, a separate container, which is, for the most part, a virtual machine, but there's much better resource sharing. If you ever installed VMware or other means of starting a VM on your machine, and you tried to run two operating systems side by side, you know how much resources that takes up, and you have to specify, okay, this VM is going to get 2 cores and 2 gigs of RAM. With containers, we're not doing that. We can share resources between containers and with the host machine much more efficiently. So effectively lightweight VMs, which is what we like. We can run thousands of containers on a machine, potentially, and actually do that. You couldn't run thousands of VMs on a machine. Yeah.
It's just a VM without the entire OS?
My knowledge is kind of limited on that, what exactly it does, but it works with a hypervisor, which is monitoring each of them. Like, we have a hypervisor above all the containers, whereas I believe with virtual machines, you would create your own, well, it wouldn't even necessarily need a hypervisor, but there's something supervising like all of the containers and the host machine and managing all the resources, which is the hypervisor. Virtual machines don't rely on the hypervisor. They just say, here's a section of my hard drive, here's a few cores, here's a few gigs of RAM, go do your own thing. So containers are more managed. But like I said, my knowledge is kind of ends there. You'd have to do your own research on that. To get into the mechanics of how containers work. I like to just think of them as lightweight VMs, and that's good enough for me, to be honest. So anything deeper, you have to go elsewhere. Docker is the software we're going to use to create containers. We're going to create Docker containers. Docker is software that you have to install. Go to the Docker website, install Docker, and then you'll have Docker. But it is software you have to install. So the workflow is install Docker on your laptop, write your code, install Docker in production, deploy your code, same exact environment, Shouldn't have any issues. They're, as with anything, they're obscure and, some really wild errors that you can get with Docker, but they're much, much fewer than if you tried to configure two machines and just tried to get them as close to the same as you can. That's pretty tricky to do. Docker's going to get us like 99.9% of the way there. Docker's going to work off Docker files, which I don't even know if you see make files anymore. We used to always use make files in 250. That's long gone. I don't know if you've seen make files. I always use this comparison. I don't know if I can rely on it. How many of you have seen a make file before? Oh, yeah. Okay, so it's like a make file. Then I don't have to talk about it anymore. It's like a make file. It's going to be a script that sets up your containers for you. So we want to talk about how to set up one of these Docker files. We're going to set up a Docker file and tell Docker to use that Docker file to create images. We're going to use those images to create containers. So let's take a look at what a Docker file is like. So here's a sample Docker file, admittedly a little more complex than the ones I'll show you later. I'll show you a little bit easier way. But this is an example Docker file. And I'm just going to go through this thing line by line and show you what it's doing. This one is going to run a JavaScript app, a Node app. Let's just talk about how it works. All right, so the first line of your Docker file is going to specify a base image. So there are all kinds of images out there available for free online. And you could start with the base image just by saying from, and then the image name that you want. I'm going to say from Ubuntu 18.04. And this is going to give me an image that's available for free online and download it that is just base Ubuntu installed. Just Ubuntu, nothing fancy. But I'll have that entire operating system, just one line in a Docker file. Give me an Ubuntu image. Then we're going to run commands, run RUN in all capital letters, and that's going to execute commands as though you were typing them into the console. So if you had a fresh install of Ubuntu, you went into the console, or the terminal. What does Ubuntu call it? I don't remember. But you go into the, I'll just say command line, the general term. You go into the command line and you type apt get update. This is doing the exact same thing. So run is going to run commands effectively in your command line. It's going to run as though it were a bash script, if you want to think of it that way too. So I'm going to update apt just to make sure that I have all the repositories that I need and all that. Next, this you can get away without doing this. I like to do it personally, so I left it in my example. But I'm going to set an environment variable. I should say you don't have to set this environment variable and change this working directory, but I still want to show you what environment variables are. So if you want to set an environment variable, not what they are, but how to use them in Docker. If you want to set an environment variable, env. Env, space, name of the variable, space, value of the variable. So I'm going to set the home environment variable, which is the variable that stores the name of my home directory, and I'm going to set that to /root. So I'm going to say my home directory is going to be /root. But in general, this is how you would set any environment variables that you want to use. So if you want to use environment variables in your Docker container, this is how you can set them. Yeah?
When you say /root, would we be replacing that with like the actual directory of our...
It's whatever you want to name your directory. So the user is when the Docker file is running, it's going to be running as root in the Ubuntu container that I'm creating here. So I'm going to name it root because that is the username of the user that's going to be running these commands. But you can name that directory whatever you want.
Oh, okay. So by default it's root, so we can just use that to set the environment variables and working directory?
Yes. Yeah. But well, by default, I don't actually know what it would be by default. That I always set these so I don't have to think about what the default is. So I don't know what the default home directory is. It might be /root for all I know. But this way, I know what the home directory is going to be. In the next line, I'm changing the working directory, so I'm going to enter into that directory. And I just want that to be root. It could be whatever you want it to be. I use it as root just to remind myself that I'm going to be executing these commands as root. We don't have any sudo here or anything. We're logged in as root. We have full access. Yep. Yes? Put what? On this one? This one? No. So this is a separate command. So env is to set an environment variable. So on Ubuntu, you have, or Linux in general, you have an environment variable named home that's going to store the value of your home directory. So like if you go cd tilde, that's going to take you to your home directory, for example. This is specifying which directory it should take you to. Working directory, work dir. This is a separate command that's going to change the current working directory, which is the same as typing cd. So this is the same as saying cd/root in the command line, except in a Dockerfile, you use work dir instead of cd. So I'm going to change my working directory to root. So now I know by setting these two variables, again, this is something that I like to do. By setting these two variables, I know what my home directory is, and I know that all my commands following these lines that I execute are going to be executed from my home directory, and I know what that directory is. I like knowing those two things. So I'm saying my home directory is going to be root, and I want to enter that directory. Like I said, for all I know, this might happen automatically. This might be redundant, but if I had these two lines, I don't have to ask any questions. I don't have to rely on Docker updates and changes the defaults, and now all my stuff's broken. I have these two lines. I don't have to worry about it. I know I'm in my directory named root, and I know that's my home directory. So I like to do it. After that, I'm going to run whatever commands I need to set up any software that I want to use. So if I'm starting with just vanilla Ubuntu, I'm going to have to install, at the very least, all of the software that I need to use my programming language of choice. So this is going to be a Node app. App www.js is going to have all the code for my actual app. So I'm going to have to install Node. So these three lines are going to install Node for me. I have to do update fix missing because without that, things don't work, and that's what the documentation tells you to do. And install Node and install npm Node's package manager. So I'm going to install those things. Now I have Node set up. Anything else you would need, you'd have to, of course, do that too. Should I answer that during lecture? Somebody's asking about 116 labs. Then a very important command, copy. The container is just Ubuntu. We want to get our code in there. You need your app's code in the container, or else what are we even doing? Copy is going to get your code into there. Copy takes two arguments, and these are both directories. The first argument is going to be the directory, or it could be paths, I should say. In this case, it's going to be a directory. You could copy a single file also. That's valid too. I'm giving it a directory. I'm saying copy from this directory on my local machine and copy into this directory inside the image, inside the Docker image. So for my case, I like copy ... Copy from the current directory on my home machine. So I'm going to put my Dockerfile in the root directory of my project, and I'm going to say copy everything in this directory into the Docker container at the current directory. Dot is the path for the current directory, whatever directory you're currently working in. The second one is inside the container, which I already know that that's /root because I set it as /root. So it's going to copy all of my files from the current working directory, the directory that the Dockerfile lives in, into /root inside the container. If you want to manage different directory structures, by all means, you can change these instead of doing ... I like this because I like this line. It looks nice and clean. Copy ... But there's a lot of meaning in those dots. So just be aware of what those dots are representing. And then, the order is important here, I'm going to install all my dependencies. For Node, npm does this. npm install is going to look for package.json file, which is going to have all my dependencies, and it's going to download all those dependencies for me. The order is very important here. You have to think about what's happening in this Docker file. For example, if I run npm install before copying my files over, what's npm install supposed to be doing? It's not going to find a package.json file because we haven't created one and we haven't copied anything into the container. npm install is going to say, couldn't find package.json. It won't crash. It won't give an error or anything. It'll just be like, there's nothing to install, so I guess my job's done here. Then you copy your files in and then try to run your app without your dependencies. So you got to think about the order here. These commands are running inside the Docker image at this point, running inside the Docker image. So you got to make sure your code is in the image before you install dependencies. So just think about what each line is doing. I've seen these lines out of order in office hours quite a bit. And well, actually, I don't anymore because students just copy my Docker files that I show in the slides. But I used to when I didn't give the code. I would see these out of order all the time. And then I have the student think through what they're doing and explain to me what the Docker file is doing, and they usually find their mistake. I want to expose a port. This app is going to run on port 8000. Now, by default, all ports are locked down. Your container's in isolation. You don't want anybody breaking into that container. So when we do want somebody to access the container, we're going to explicitly say this is allowed. So I'm going to say port 8000, let people from outside the container access my port 8000, because that's where I'm running my web app. What's the point of a web app if it's in complete isolation and nobody on the internet can access it? It's kind of pointless. So let's expose the port that our app is running on. And then finally, command, CMD. This is where you're finally starting your app. You're actually running your code. And it's very important that you use command for this and not run. Run is going to run those commands when the image is being built. So you want to use run for any setup of your container. But when it comes time to actually run your app, use command. Command is going to be executed when the container is ran. So you create an image, you create a container from that. Well, I'm getting ahead of myself. But whenever you start the container, command is ran. That'll run every time you start your container. Run is only ran once, only when the image is being built. So the difference between run and command, very, very important. And you should only have one command. I believe only one is allowed. I've never wanted to have more than one. Only one is allowed, but you can use ampersands to run multiple commands if you want, but you can only use one command, I believe. I've never tried to do it with two. I think it breaks. I think I saw that in office hours one time, and that was the bug. But one command to run your app. And that's a little bit of a pain. I said there's tons of these images, these base images out there for you. And lucky for us, there's a base image for pretty much any programming language, or probably any programming language you'd want to use. Somebody made a container, started with Ubuntu most likely, had a Docker file that installed all the stuff that you need for that language, and then hosted that for free for us to use. So why not use them? So this is the Docker file, which does effectively the same thing as the one that we were just looking at, except I'm going to start with an image of Ubuntu with Node already installed. So now I'm skipping that updating apt. I'm not finding my missing dependencies. I'm not installing Node. I'm not installing npm. I'm getting rid of all those lines by starting with a base image that already has the stuff that I want. So I recommend searching Docker language of choice. Find a Docker image with all of everything you need pre-installed on it, and then cut out some lines of this Docker file. I'm still going to leave the rest of this stuff. Obviously, you have to always copy your stuff. I'm still going to switch my stuff to root. I still have to run npm, but I don't have to install npm itself. Still expose and still run my app, but I cut out all that setting up Node lines. And of course, I recommend Python, so I better show you a Python example. From Python, and then the version number, 3.8 was the latest at the time of making these slides. If you want to use newer features, you'll update the version of Python. And then setting up my directory the same, copying my files the same, except there's no npm for Python. We're going to run pip install. To specify requirements in Python, you have a requirements.txt file, which is going to list all of your dependencies. Pip is going to install those for you. So we're going to tell pip, hey, install all of the dependencies in requirements.txt. I see this far too often, so I gotta say this. If you don't have a requirements.txt, maybe comment this line out. It's a frustrating one to see in office hours. My Docker container's not building. What's this line doing? Oh, I don't know what it's doing. I just copied it off your slides. Do you have a requirements.txt? No. Do you have any external dependencies? No. Then what are you doing that for? It's a frustrating one. But if you don't have a requirements.txt, maybe comment out this line. And I'm still going to expose the port that I want, and then run Python to start my app. This -u is a lifesaver. Before this, life was bad. This -u, just put it there. Don't ask questions, just put it there. Python, when run inside a Docker container, will buffer the output. So when you're printing things to the screen, you want to print out the HTTP requests and stuff, print out your responses before you send them so you can verify that things are working the way you want, and you don't want to write up unit tests. That output will be buffered by default, which means if the buffer's not full, you don't see your output. And the buffer's pretty big. So you would run your app inside Docker and not see any of your print statements. Until you close the container, then it'll unload the buffer, it'll dump it all out, and then you get to see it. Before I knew about this -u, you can explicitly flush the buffer in Python by doing system, flush the standard out, flush standard error, and I'd have students pasting those all over their code, so it would flush the buffer constantly. -u says, run this unbuffered. So don't buffer anything, just print to the screen immediately. So with that -u, you actually get to see your print statements, which is a nice thing to have. It's a nice feature to have. So luckily, that's less of a pain. Just put that -u there, and you don't have to even worry about anything that I just said. You'll be able to see your print statements. Okay. So now that we have a Docker file, we can create Docker images. To do that, Docker build -t, and we're going to run this in the directory where our Docker file exists. Docker's going to look for a file named dockerfile with a capital D. I think it does look, it starts there. I think it does look for with a lowercase d and a couple other variations. I believe, I don't know, just name your Docker file with a capital D, though, it'll to make sure it'll find it. I'm not sure on the progression of that. So Docker build, run this command in the directory where your Docker file is, -t, so you can name the image, or else it'll give you a random name that doesn't make sense. And then image name, whatever you decide to name your image, web app or whatever you want to name your image, space, and then a dot. Oh, I did misspeak a little bit there. Let me clarify. This dot is important. This is just like the copy, the dots on copy. This is specifying the path to your Docker file. So if you run this in the directory where your Docker file is, and you say just dot, that says look in this directory for a Docker file. So the command, I misspoke. By default, the command doesn't look in the directory that you're in. So if you want to, for whatever reason, I don't know why you'd want to, but if you want to build an image from a directory other than the directory where your Docker file is, you would specify the path to tell Docker where to find the Docker file that you want to work with. I guess if you're writing scripts and you want a script that runs a whole bunch of Docker files, it builds a bunch of images, maybe you'd want to use that. That will build your image. But we don't even want images, right? We want containers. That's what we're actually after. So an image is like a class. The containers are like objects. We need the class to be able to instantiate objects. So with one image, we can create many copies of that container to our heart's content. This is how we can build big distributed systems. We have an image, and we just use that image to build a whole bunch of containers. To build a container off of an image, we're going to use docker run -p, which stands for publish, then a port mapping. We're going to map a local port on our machine to a port inside the container. And this is where that 8080 versus 8000 question comes in from last time. We're going to map a port from our local machine. When I say docker run, my laptop is my local machine. I'm going to say this port on my laptop. I want that port to map to port 8000 inside my container, because 8000 just happens to be the port that I'm running my apps on in this example. So in my Dockerfile, I exposed port 8000, which I believe publish will automatically expose the ports, but I like to be redundant to make sure. Then map that to port 8000 inside of the container, because that's where my app's running. So now when I get a request for localhost local port, which will be 8080 in our case, when I get a request for port 8080 on my laptop, Docker's going to be listening on port 8080 and say, oh, I know what to do with this request, and it's going to forward that to port 8000 inside my container. So what's exposed to the world is going to be that port 8080, and nobody cares what port I'm running inside the container. That's not exposed to people. You can use whatever port you want inside your containers as long as 8080 is exposed outside of your container, as long as 8080 is the local port. Yeah?
So you need a Docker file that's inside Docker that you write that creates an image, then you create a container.
Yep, exactly. And then image name, this matches whatever image name you chose when you created your image. Yeah?
Sorry, could you repeat that next local port 8000 and then the other port 8080 being local port?
Yeah. Let me check the time. Let me do that in, this is my last slide, right? Oh. I'm going to jump to the command line and run a command. The short version is it's mapping a local port on my machine to a port inside the container. So if I do 8080:8000, and somebody goes to localhost 8080, they're going to access port 8000 inside my container where my app's running. Putting a -d here, you don't really need to do this in this course, but when you go to deploy in production, -d is going to run that in detached mode, which means you get access to your command line. It just runs your container in the background, which is what we want in production. In development, we usually don't want to use detached mode, because when you use that, you can't see your standard output without accessing the log files. I said that a bunch of times. And whenever you're coding your app, inside the code, we saw this in my examples, don't use localhost as the host. Use 0.0.0.0. If you do localhost, you won't be able to access your app when it's running inside a Docker container. Make sure you're using this zeros as a host. All right, let me quickly do this, because I want to show an example. We don't have an example day scheduled until next Friday, so I want to get something in here. So here's my Docker file for Python. I'm going to put it right next to that server that we saw. This is the server we saw last time. I'm going to make sure I have zeros for my host, not like documentation will say localhost. That's what you'll have there. Or just no host at all, and it'll default to localhost. Make sure you do zeros. Yeah.
Is it okay if I recommend a specific Python version for Docker?
In your code, you can use whatever Python version you want.
Okay.
Yeah, you can change that. So I'm going to copy all the files in. I'm going to run server 1. And yeah, if you want to change this to 0.9 in yours, I don't care. You can use any language you want, so versions of languages, I don't care. And then I'm going to, since I'm a little short on time, I'm just going to hit my up arrow instead of typing. Docker build, I'm going to name it Python server, and then dot. This is going to build your image. It's going to go really quick here. It's already done. The first time you do it, it's going to take a long time because it has to download all of Ubuntu and that base image. It'll take a long time the first time, but after that, it'll go a lot quicker. And then to run it, here's where I want to give a little more depth there. When I run it, I'm going to publish. So my app is running on port 8000. In my Python file, it's port 8000. So I'm going to map my port 8080 to that port 8000 inside the container when I run this. So now when I go to my browser, I'm going to go to localhost 8080, and then Docker is going to get that request, forward it to my Docker containers port 8000, and then whatever that responds with, that's going to be forwarded back to my browser. So Docker's going to route my local port 8080 to the container port 8000. And then I can see all my output, my app's running. It's doing the same thing that we saw last time, except now it's running in Docker instead of on my host machine, on my laptop. I mean, it's still on my laptop, but you know. Any questions on that? Cool. Have a great weekend.